Okay, good morning. Good morning and welcome to the opening of the main proceedings for Q2B 2019. Thank you very, very much for coming and making time in your very busy schedules to be here. We spent literally the last 6 months pulling together the most high quality content that we could possibly have done, and we have a great program for you today with a lot of luminaries, individuals and institutions from the quantum computing community and the business community. So we're really looking forward to this engagement. I just want to spend a couple of really brief moments setting the stage to remind everyone what the mission is of this conference, and then to talk about kind of the teamwork aspect of what we do here at Q2B. So perhaps the most interesting question, the interesting open question that's being asked about quantum computing is, what are these machines good for? And in fact, on the way to answering that question, over the last 2 or 3 years, there's been a lot of development of use cases and a lot more activity to address this question. And really, I think the biggest reason for that, for this explosion kind of, is the entrance of the enterprise community joining up and talking to the quantum computing technology stack. So the enterprise community, that's all of you out here, you have all of this domain expertise, you have the hard computing problems, and you have the data. And bringing that together with experts from the quantum computing community is really what's going to help stimulate the development of applications, and truly what we say is application discovery. So we're not even at the stage yet really in this industry where we're just coding up applications. It's really coming up with these use cases where we can have some sort of a quantum advantage to run those problems. And what we want to do at Q2B is help to accelerate that application discovery a little bit by, figuratively speaking, putting everyone in a room together and locking the door for 3 days and having all of this collaboration happen. And when we think about this collaboration, what we really think about it is a form of teamwork. And when we think about teamwork more deeply, we can't help but notice the parallels between the teamwork we're trying to foster here and the kind of teamwork that you see in a really high-performing athletic team. And yes, my talk is not at all going to be technical. But in particular, what I want to try to do is to talk about some of the lessons that we can learn from a well-oiled athletic team and how that really relates to us here at Q2B. So the first lesson is that we want to use the talents of everyone in this room, just like on an athletic team, you want to use everyone on your team. So I'm going to show a video that's going to illustrate that. And in this particular case, we're taking a scene from professional basketball. The Cleveland Cavaliers have the ball, they're driving down the court. Their objective is to get the ball into the hands of one of their high percentage three-point shooters, and at the same time they want to pull defenders away from that shooter so he's got a clean shot at the basket. So let's look at how this plays out.
Cavaliers playing with a lot of pace in this game. Boy, what a find by James. Cavaliers with the extra pass. That has to go in. I mean, they passed that ball, Doris.
Okay, awesome. And you notice that LeBron James there wasn't the shooter. He shoveled the ball off. That's real teamwork. So we've got our own team, and we've got our team players. And our team now, actually at last count, in attendance today are 535 attendees, which is actually more than twice it was 24 months ago when we did Q2B for the first time. Perhaps the most important player on our team are the enterprises out there. That's the group that we've really wanted to pull into this. Right next to them are the quantum computing hardware and software companies with all of the domain knowledge in quantum algorithms and quantum information. Now, those hardware and software companies are being supported, at least partially, by risk capital that's coming from the venture capital community. There's another stakeholder that we have here, and that's government agencies that are doing work on a lot of different levels. We have, at kind of in the US anyway, and at other national levels, policy and programs are being set up. Then you've got at kind of agency levels, you have the DoD, the DOE, and the National Science Foundation that are putting funding and support across to these universities and labs. And you've got one other thing in a US context that's really interesting, and that's what, through the National Quantum Initiative, the Department of Commerce has set up something called the Quantum Economic Development Consortium, and sort of the chairman of that, or the overseer of that in the Department of Commerce, is Carl Williams, who's here today, and I'm going to talk a little bit more about the QEDC a bit later. We also have Joe Brose, I think, in attendance today, who's the executive director. So I'll come back to that. But let's talk about the universities and labs for just a little bit. This is actually the real engine for all the invention and discovery that's happening broadly in the quantum computing community. And so this is really an anchor participant, so we're very happy that we have a really deep involvement from that community. Now, as with every team, there's a couple players that we really want to give particular recognition to. So back for the second year in a row, the Air Force Research Laboratory is the platinum sponsor of Q2B, and we're really happy to welcome back AFRL to the Valley, and thank you very much for your support. Today you're going to hear from Dr. Mike Haydick. Tomorrow you're going to hear from Dan Koch from AFRL. We also have a set of the leading hardware builders, hardware developers, as returning sponsors from last year. We have IBM, Microsoft, Google, and Rigetti. We also have new sponsors coming on to Q2B for the first time this year, Honeywell and Xanadu, and we'd like to thank all of those groups. Now additionally, there's been a lot of additional material support provided by perhaps somewhat smaller groups that are nonetheless really important to Q2B, and we really couldn't do this without them. And I've kind of arranged these sponsors in sort of a technology stack. So of course we have D-Wave, which is a powerful hardware provider, Quantum Benchmark, Quantum Machines, IQM, that's more on the enabling technologies and hardware side. We have our fellow members of the quantum computing software community, Cambridge Quantum Computing, Horizon Quantum Computing, and Zapata. Then we have members of the user community that have sponsored, so that's Citigroup, Bear, and X, which as you know is the kind of moonshot unit of Google. And then we have more national level laboratories. We have Brookhaven, the government of the Netherlands through Quantum Delft, the Dutch government also sponsored last year, Inside Quantum Technologies, and of course USRA, which is a key sponsor and is sponsoring in particular the major academic talks that are happening today. So now that we've got the team assembled, the next most important thing you want to do is get everyone rowing in the same direction. And the best way to do that is to say, do you see that lighthouse over there? That's what everyone is rowing towards. So you need to have a very tangible goal. And in the field of sports, if we go back to that, I'd like to take you to another example. In this case, go back to 2011 to the Women's World Cup Soccer Championship. Brazil is playing the US. At the end of regulation time, Brazil is ahead 2-1. There was a little bit of stoppage time put on the clock. This gives the US a chance to tie the game. If they can tie the game, there'll be a shootout. If they win the shootout, they can advance in the World Cup. If they don't, it's all over. So let's look at how that played out. And my apologies in advance to everyone from Brazil here.
Now, USA have it. And they've just got to get everybody forward now. No sense defending anymore. Lloyd's got to get this pass off to Rapinoe, and everybody's got to bond forward now. Rapinoe gets a crossing. It's towards one. Has saved the USA's life in this World Cup.
Okay, we cannot promise that every day in quantum computing, you know this yourself, is not that adrenaline fueled, but we do have tangible goals. The first one we've already talked about. There's no need to dwell on this. The second goal is linked very closely to the first. You have to understand the early development stage of the quantum computing resources we're working with so that you can figure out, okay, what can we do with these very early generation these resources. Now, I want to take a little bit of a step back and talk about this for a second. At last count, there were a total of 34 commercial, fully funded quantum computing hardware programs across the world. And those are the ones that are disclosed. There'll be others not disclosed that will become more visible. The number of quantum algorithms that have provable end-to-end speed-up potential, and provable by people like Umesh Vazirani at Berkeley, who specializes in complexity theory, or Scott Aronson, the number of those is something like 4 or 5 or 6. That's completely lopsided if you look at the equivalent in the classical world. So when we talked about the Department of Energy, the National Science Foundation, the DoD, what we'd like to suggest is let's put a lot more resources, a lot more money into universities in particular, because that's where a lot of this discovery happens, to develop more quantum algorithms so we can do more useful things and have a much larger set of problems that we can do things with. But back to the goals. So if during Q2B for the next 2 days, 50% of these seats are not filled because everyone's out in the hallways or in meeting rooms talking about research collaborations or commercial partnerships, then we've really accomplished our goal. Because what we're really trying to do is bring everyone physically together, get to know each other, get some trust and confidence built up, and seeing where there's some alignment on where you're trying to take your businesses. So, another teamwork lesson. So General Dwight D. Eisenhower is credited with popularizing this quote, "Planning is everything, the plan is nothing." And what he really meant by that is, hey, if we have a team, we have to train, equip, and make them proficient and get them ready for a contest. But at the same, that's the planning part. But at the same time, once the contest starts, there are all these external forces acting on that team that they really have no control over. So you have to be creative, you have to improvise. So once again, let's take a look at a sporting example of this. In this case, you have Duke playing college football against the University of Miami. Now, Duke, as all of you know, has a great quantum computing research effort. Like Jung-Sang Kim was at Duke University. He's exported all of that into IonQ's hardware platform. That's really good. But Duke as a football team is terrible. And as a matter of fact, this is true. If you had Duke's quantum computing group playing Duke's football team in football, Duke's quantum computing team would win by a lot. Like they would crush them. But nonetheless, in this case, there are 6 seconds left to go in the game, and miraculously, Duke is up by 3 points. Duke is kicking off to Miami, so Miami has one attempt to score a touchdown. They need a touchdown to win. And so what Miami said is, let's do this trick play, this choreographed trick play. We've practiced it. And when they started executing that, it went to plan, and then they had to improvise to succeed. Let's watch.
Give him the 35-yard line with 6 seconds to go.
Might not be a bad plan. Going to be a lot of rugby going on here.
Take it short. Lateral. They practiced that on Wednesday. Time's going to expire on the game, so this either goes or it doesn't. Ball's still alive. It's got to be backwards lateral. Get behind it. Still alive.
Duke doing a nice job staying spacing all over. Oh, he got a block.
Blockers. They got blockers. They've got a lane. 40-yard line. No black shirts between the goal line. Can you believe what you just saw?
That was excellent. Did you notice, by the way, on Duke's team, number 23, that was Jung-Sang Kim. He missed the tackle. And he still got a scar. You can check on it on the break. But anyway, at Q2B, we do actually have a plan. You missed the first phase of the plan yesterday if you weren't here, the boot camp. We do have a set of talks that are really good. We're going to kick off today with 2 major keynotes, John Preskill and Dr. Mike Haydick. And then some of the major hardware developers are going to describe to you their hardware programs and roadmaps. Tomorrow, we're going to start with a single stream day. The key notable talks tomorrow are going to be Umesh Vazirani from Berkeley. I think most of you know. We'll do a more formal introduction tomorrow. And then in the early afternoon, Scott Aronson is going to do a lively, entertaining, and probably quite humorous Ask Me Anything, so don't leave before that. But mainly tomorrow, the main thing is going to be 4 individual tracks. 3 of the tracks, each of them will be devoted to each of the 3 general major problem classes that quantum computers are working to address: optimization, simulation, and machine learning. And there's a 4th track for software, which, as we all know, is this important bridge between quantum algorithms and this vast number of users that have no presumed background in quantum computing but want to access these machines just like they access other accelerators, or this was a future accelerator, like GPUs and FPGAs. So that's the plan. The one thing I want to mention, I talked about the QEDC a little bit ago. Now, Joe Bros just walked into the room. The QEDC is a government-sponsored initiative to mobilize the private sector to promote the development of quantum technologies, and quantum computing is something really near and dear to the QEDC's heart. So if you're a company who's not yet a member, and many companies already are, I would urge you to talk to either Joe Bros or Carl Williams. Joe is moderating a government panel this afternoon, so you'll have the face name recognition going at that point. Anyway, what's the improvisation side of Q2B? Well, that's all of the breaks between sessions. Those are lunches, those are dinners, and in particular, it's the happy hour today. But then it's the other 362 days of the year when nobody is here, but you're all doing all of this stuff remotely. That's what we really want to see. Now, very quickly, I want to talk about the last lesson, which is the absolute most important lesson we can have, and that is to keep trying. There is a lot of experimentation and exploration that still has to be done to develop useful applications and develop hardware that can run those useful applications. But I want to take an example from sports that illustrates this. This is Wayne Gretzky. Wayne Gretzky is the greatest hockey player ever to set foot on the face of the earth. We've picked ice hockey as, for one reason, it's kind of a nod to our friends from the north, the Canadians, who have a disproportionately large quantum computing program going. They really punch above their weight, much like the Australians and the Netherlands in quantum computing. But the other thing, of course, they do is produce great hockey players. I'm going to show you a clip from just one of Wayne Gretzky's 982 goals that he scored. He scored more goals than anyone else in the NHL. And then I'm going to tell you why this is relevant. So let's watch.
Lume pinching in, and he's caught. Here's Gretzky with some room with Mike Keane. Gretzky dancing in on the backhand. Wrap around, scores! His 50th hat trick, Wayne Gretzky.
That thing Wayne Gretzky did in the back of the net, they called the back of the net, behind the net, they called that Gretzky's office. That's where he went to work, and that's actually true. So why did we show that? It's because not only did Wayne Gretzky score more goals than anyone else in NHL history, and anyone else ever will, including Alex Ovechkin, who will never catch him, even for those of you from Washington. But here's what he did also. He probably took more shots on goal than anyone else in the history of the NHL. And that's key. And that reflects what Wayne Gretzky's most famous quote is this: you miss 100% of the shots you don't take. And so this is sort of like in quantum computing when you have these kind of churlish, droll people who sit on the sidelines and say, man will never fly, you'll never get a man on the moon, and you'll never build a quantum computer that's going to do anything useful. They could be right about that third thing, but you absolutely have to try. You have to experiment.